continuing in 12.1. Example 6 is just practicing basically how to put it in your calculator. But it says if you have a wheel of a bicycle and you've put a flashlight on it and you're tracing the path of the light on the rim of the rolling wheel, it has parametric function equations that look like this. And y, this is x over here. T is going to be y is going to be a times 1 minus cosine t, and t is greater than or equal to 0. And it wants us to use a as 1. Usually a is a number greater than 0. But for this problem, they want you to go to your graphing calculator and put in 1 for a. And then 1 here. And graph those. Now, on a TI-84, you'll need to go to mode. And when you go to mode, you'll move down to function and go over to, it says FUNC, move over to PAR and hit enter on that so it's black. Then when you go to your y equals, you see x, hit the y equals button to put the equations in. You have x1t and you have y1t, and that's where you put these equations in. Now, where does the t come from? When you hit that x button that's next to your alpha button to get your variable, because you're in parametrics, it will automatically put a t in there. It says x comma t comma theta comma n. It's a toggle button. Depending on the mode your calculator is in, it will put in the appropriate letters. So it's going to put t's in for you. Now, if you go to window at this point, you can look at it and it'll show you what it's using, and what you're looking for are the t's. And I think the default setting on it is to set your t to go from 0 to 6.28, which is 2 pi. So when you let the calculator graph that, you only see this. If you were to change it to go to 4 pi, then you would see another one come up. So this is 2 pi. And the question said, on what interval does the parameter generate an arch of one arch of the cycloid? It generates it from 0 to 2 pi. So that answers that question. So the trick is to go to window and look at what it's using. And then you can change that window, make it a 4 pi, and then you can see more of it. So now we're up to example 7, and this is more rolling wheels. Okay, the point on a circle A with radius A over 4, R equals A over 4, rolls on the inside, well, this is circle A, on the inside of circle B that has a radius of A. And the first one was called a cycloid, example 6. But this one is an asteroid or a hypocycloid. In other words, it's a cycloid, but it's inside out. And the parametric equations for this one they're saying are a cosine cubed of t, y equals a sine cubed of t. And this time they are specifically saying just 0 to 2 pi. So they want us to put a as 1 and find its equation in terms of x and y. Okay, so the first part, you're just going to put it in your calculator, the way I showed you in number 6, and graph it. And it's kind of an interesting graph. It does this number. It goes this way, then this way, then this way, then this way. The arrows are hidden like this. And you can kind of see that it's inside out. So it's called an asteroid. So now to eliminate the parameter, this is where it gets kind of weird. What you have to notice here, remember we're putting a 1 in there, so this is actually what we have. So what we want to do is we want to notice that x to the 2/3 would be equal to cosine squared of t. If you took the cube root of that cosine cubed and then squared it, that's what you would get. And the same thing happens on this one. Y to the 2/3 would equal to sine squared of t. So we could write x to the 2/3 plus y to the 2/3 would equal cosine squared of t plus sine squared of t, which we know is 1. So my equation would be x to the 2/3 plus y to the 2/3 equals 1. And we're using the Pythagorean identity there.